I want to begin today, though, by mentioning that we are in the beginning of a fundraising and fundraiser for the Senior Center for the next couple of weeks. And so I invite you to look on our website to figure out how to sign up for the daily trivia contest, which could win you a gift certificate at the Waterfront Thrift Center. And as part of this fundraiser, we have sponsors for each day. And today's day sponsor is Windermere Bainbridge. They have a little message I'd like to share with you. Windermere Bainbridge is committed to the communities in which we live and work. Through the Windermere Foundation, our annual Community Service Day, and a variety of community events, Windermere brokers, owners, and staff work together to help build and sustain thriving neighborhoods all across Bainbridge Island. So thank you to Windermere for helping with this campaign. And I also want to give a big thank you to McKinstry, which is the organization, the company that we're going to hear from today about ventilation and the challenges of a healthy building. And I think that some of this will translate into our own healthy environments as we try to figure out how to live safely in a world that requires a little more ventilation to prevent a particular virus and other things from crimping our style a little bit. So Keith Bass is the person who I asked to talk to today from McKinstry, and he's also joined by Brian Jenkins, and maybe we will hear from Larry Mayotte a little bit later. So without any further ado, I think I'll just hand over the keys to the kingdom here to Keith, and welcome. Thank you very much for coming. We have some questions for you, but I know you want to start by telling us a little bit about McKinstry and what the firm does.
Yeah, I really appreciate that, Reed. Thank you so much. It's a pleasure to be here with you. I am going to just pull up a PowerPoint for no other reason, just to serve as a guideline and just kind of keep us on track. And can everybody see that? Hang on one second. I'm gonna put it into a presentation mode.
Yep, it looks good.
Okay, you see that? Great. Yeah. So as Reed mentioned, my name is Keith Bass. I'm with our technical services team in the Seattle office. I actually live here on Bainbridge Island. I've been here about 10 years. My background, I started with McKinstry only a year ago, but I've been working in the, I guess, energy resource space, helping multi-site commercial industrial customers get the most out of their buildings for well over 30 years. Started my career on the utility side of the business and worked for a couple of utility companies, and then helped start a company over in Spokane that grew out of a Vista Corporation, which is the utility that serves gas and electricity over in eastern Washington, northern Idaho. And I was there 20 years with that company. Left, made my way over here. My wife was from this area. We have 2 small children. I started very late in life, and I got a 11, 13-year-old, and we wanted to get them into a good environment to raise them. And Bainbridge was the area we chose. So we're happy to be part of the community, and this is very special for me to have a chance to present to you folks today. I'm going to ask Brian maybe take a minute. You know, we got a good cross section of people to visit with you today. Brian, I'm going to let him tell about himself. But the thing is, his career, his background is actual day-to-day working with equipment with HVAC. He's a certified HVAC tech. But I'm going to let him expand on that a little bit. Brian?
Yeah, thank you, Keith. So my name is Brian Jenkins. I've been with McKinstry now about 4 years. Prior to that, I worked for a company that was an equipment rep, so we sold HVAC equipment. So I helped in the kind of mostly for the K through 12 and some colleges and government projects, but we sold all kinds of HVAC equipment. So I helped kind of design that, the systems, lots of kind of geothermal, high performance, high energy efficiency systems for school districts and colleges. So we help sell the equipment as well as commission it, maintain it, and do service work on it. I did that for about for 10 years, doing installs and design work and commissioning. And then I also joined, then went up to McKinstry as a union service mechanic. So I kind of was in the McKinstry service department for about 2 years, running service, doing all kinds of different service projects. And then the last 2 years, I've been over in our active energy management, our technical services department. So kind of bringing my knowledge and skill set and data analytical abilities to our active energy management programs, including our Return with Confidence program, so that we have for our kind of COVID guidance. Which is what we're
Okay, thanks, Brian.
Yeah.
Larry, has Larry been able to join? I know he had an emergency pop up today, so he may not be able to.
Yeah, I haven't
make it.
seen him.
Oh, hey. Okay, great. Okay, well, let's just a quick overview about McKinstry for those of you may not be familiar with it. McKinstry is a Seattle-based company, started 60 years ago, started as a plumbing shop initially, and then from there got into construction and doing design build work. And today it's we've got our hands into just a lot of things, and we've grown well beyond just Seattle. We have offices as far east is Chicago. We're even involved in a big project down in Florida, about 2,000 employees. We do trade. We've got a trade group, electricians, plumbers, HVAC techs. We've got probably a couple of hundred professional engineers. So just a lot of work in a lot of different areas. And so we understand facilities, we understand the way they work, and so it puts us in a good position to help customers in this with this COVID issue that we're facing. One thing I'm real proud of, and I think I think it'll resonate with the people here on Bainbridge. Last week we announced that we joined Amazon and the Global Optimism group, signing the Climate Pledge, which is basically stating that by at least 2040 we will be net zero, the way we operate our business. And our goal is to do it by 2030. Dean Allen, who is the son of the founder of McKinstry, he's our CEO. He's very active in the pursuit of net zero initiatives. In fact, we just had a event last week where we did a grand opening of a building we built over in Spokane. It's actually 2 buildings. It's called the South Landing Project, and it'll house the engineering program and the IT programs for Eastern Washington University. It's a net zero eco district. It'll be one of the largest in the United States. The building called the Catalyst is built out of glue laminate beams. It's 5 stories. Just a beautiful building right on the river there in Spokane across from Gonzaga. We also broke ground last week to build another building right adjacent to it that's going to be the new medical school joint venture between Gonzaga and University of Washington. And that'll also be approaching net zero, very efficient building. So anything, something we're really proud of. So I'm heading up a program for this part of the state that's called Return with Confidence. And what we did was we recognized the need to help building owners, get their buildings ready for reoccupancy. And so we're starting. We'll offer to do a free consultation call, and then if a client's interested, we'll come out there and actually look at their facilities. And kind of the reason we introduced the program is because when a building sits idle, on both the water side and the air side, there's a lot of problems that can occur. And there's specific procedures and other things that you really kind of need to take into consideration. We'll get into more details about this in a minute. But there's processes and along the lines of introducing outside air, filtration sort of issues, and other things, and even on the water side, flushing the water systems to make sure you have adequate chlorine levels to prevent air pathogens, and then even on the water with the Legionella and other pathogens that can cause problems. So we're leveraging our expertise, our ability to see best practices for the good of the community. so basically, what we're doing is we're working with clients to understand, what are their biggest issues, what are their schedules for reoccupying buildings. We do a lot with school districts, so you can imagine we're really busy now with schools. In fact, we're going to start this week. We're going to do an assessment for all 10 North Kitsap County facilities, going in and looking at their schools and looking at each HVAC unit, determine how much indoor air they can get into the units, what sort of filtration they have in place. Can they go from what's called a MERV 8 to a MERV 14, which basically just defines, the tightness of the filter and allowing particulates through and that sort of thing.
Yeah, I happened to change my own filter after our smoky week, and I noticed that there were MERV numbers on the filter. MERV 8, I think, is probably the basic one. And so we're learning a little bit more about this in the consumer world.
That's right. That's right. So yeah, the same is true for households. It is for commercial buildings. In fact, Brian, I was excited to have Brian today because, his expertise expands well beyond just commercial buildings. He also has a lot of knowledge about residential buildings, which may be more pertinent to this audience. So we can address those sort of things too. And I'm gonna not waste a lot of time going through this information. I want to kind of just jump in and just talk specifically about what you can do with your facilities, what we're kind of advising folks that are building operators or facility directors to do with their portfolio buildings. So we're helping them kind of assess their current situation, what capabilities their building has, the ability for their systems to introduce outside air, scheduling and sequencing their buildings to bring outside air in at a certain time. And it becomes more challenging. Right now we have weather like we're going to have this week. It's not that big of an issue, but later on when the weather turns, that we're still going to have the need to bring in outside air, so it gets a little more challenging. And also, it kind of goes against the grain of trying to conserve and operate your building as efficiently as possible. You're having to do kind of just the opposite. You're having to run your equipment as much as possible, try to bring in outside air or manufacture conditionings for your facility. So, it becomes challenging, and we're trying to provide that guidance to the clients. I'm gonna just take a pause right there. We're going to get into specifics about the building, and Brian's going to take us through that, things that we're recommending that clients pay attention to and provide guidance on. But I'll just stop there for a minute reading to see if there's any questions about what I've covered up to this point.
Yeah, if anybody has a question, they're certainly welcome to just open up their microphone and ask, or you can type something in the chat box at the top of the screen. I'm just curious about the number of clients that you're dealing with right now who, as you say, were looking primarily at efficiency in the past and are now facing new challenges. We've been fortunate that the weather has been pretty good in the Northwest this summer, with a couple of little exceptions, and so we've been able to have a lot of meetings outside. And I think a lot of organizations and businesses have had people working remotely. Schools are a perfect example, I guess, of a situation where people are going to want to get back together. Have you had a number of people who have reached out to you just trying to do this kind of evaluation?
Yeah, we really have. The operators of multi-site buildings, companies like ARE that operates 14, 15 large commercial research facilities. We've worked with them. We've worked with a number of school districts. I mentioned North Kitsap. We're doing a project for Edmonds. We've had a lot of calls. We do a lot of work with school districts. We are kind of we have a program called Power Ed, where we have a program where we work with the school districts on helping them manage their energy usage throughout all their buildings in the districts. And so they're kind of normal clients of ours, and so we've had a lot of calls with them talking about this very issue. trying to, create a healthy environment, but also, what do you do about the energy budget? And that's just something that is going to, end up probably taking a hit, because of what they're trying to accomplish with introducing outside air and those sort of things. Now, you mentioned the challenges, of the fires we had. So, we're in a situation where we need to bring in outside air. But when we have conditions like that, you can't do it. So you got to just lock the buildings up as tight as possible, not to introduce that. And then that's what, without that introducing of outside air to kind of, try to disperse and temper the impact of the COVID, the particulates and things like that, it makes it even more difficult and challenging.
I'm guessing Brian will be able to talk a little bit more about things like air cleaning, things like HEPA filters and that kind of thing.
Exactly. Yeah. So that's one of the big things we're doing, is helping them look at their filtration. In fact, I'm going to just turn it over to Brian right now. Brian, you want to just run through these items real quick?
Yeah, sounds good. I can just kind of jump in there. Yeah, so we do work a lot with schools. We've done a bunch of private schools in Seattle area recently as well. And yeah, their kind of main concerns are, the ventilation, what are the CDC and ASHRAE guidelines for this particular virus, and how we can mitigate that. And so we've kind of put together and kind of compiled based on our experience in the industry, working with all these clients, as well as the ASHRAE and CDC guidelines, and working with our RPEs and professional engineers in-house to kind of make some of these recommendations. The recommended, ASHRAE is recommending that you have a purges, 2-hour purge in the morning, 2-hour purge in the evening with 100% outside air. Now this pre-purge is they're recommending, if you only can do 1 purge a day, definitely recommending doing the pre-purge in the morning. Now I kind of want to.
I'm just going to jump in there because you mentioned an organization, ASHRAE, which my little internet search tells me is the American Society of Heating, Refrigeration, and Air Conditioning Engineers.
Correct, that is, and so they're kind of the standard guidelines that they're a group of an association of engineers that has gotten together, and they basically produce kind of these guidelines for the industry. So, and they've created these standards that everyone pretty much follows in order to keep a standard in the industry, right? So that's what ASHRAE is, and CDC, Center for Disease Control. So these were their kind of engineers putting their heads together based on their knowledge and recommendations. So I know you guys had some kind of questions regarding kind of air changes and how COVID could potentially spread via aerosols and stuff like that. I did read your article that you had sent us from the Washington Post there, Reed. That was definitely an interesting article. And just kind of wanted to kind of address any of those kind of questions regarding, or clarifications regarding how this particular virus can be transferred in droplets in the air, right? So to kind of, do you have a question, Reed?
No, go ahead.
Oh, okay. So I guess I'll kind of sum up it in kind of my layman's terms for you guys, I guess. Is, everyone is breathing in and out, right? You expel kind of moisture from your lungs. If you're coughing, you're going to expel larger droplets, or if you're sneezing, you're going to expel even more. And the force of the velocity of your lungs is going to push those droplets, out X amount of feet. Most of the droplets that you breathe out, gravity takes over. They're too heavy. They only go about 6 feet or more, depending on if you had a sneeze. They could go out, much farther than that. But that's the whole 6-foot circle. That's where this whole social distancing 6 foot came from. Is the majority of those droplets coming out of your breath will fall to the ground within that 6-foot radius, as long as we're not breathing too hard or panting. Now, there's been some debate on whether the virus is primarily transferred through airborne or just through respiratory droplets. It's kind of, I'm going to digress and go back to my theory is it's transferred, via water droplets, right? Now, whether those water droplets are small enough to be aerosolized and carry beyond your 6-foot circle, that is kind of the debate in the professional world right now. So where HVAC comes in and proper ventilation. Now, on what we do find, and we have found in several different studies, is that lack of ventilation definitely does cause an increase in cases of transferable cases of COVID. So, if now I'm trying to determine what type of ventilation is best to help mitigate, spread of this particular virus, that's also kind of up for debate. So going back to my notes here. So going back to each person, kind of, there's been cases of like enclosed spaces and the concern of the virus being spread via the airborne respiratory droplets. Let me digress. I'm losing my train of thought here. Sorry, guys.
It's all right.
All right.
Well, I could ask you a little bit about, okay, so you have the challenge as somebody who's trying to work on keeping the air clean. You may not know for sure how much of a danger that suspended air may be.
Exactly.
But you're still going to have to try to at least mitigate the risk if it is dangerous.
Exactly, right? So we go back to the HVAC side of things, where your air changes per hour or your outside air flushes, right? So the newer code requires so many air changes per hour of outside air to a building to help keep, we call the sick building syndrome down. So to help, keep mold from growing, obviously viral transmission, but mostly to kind of keep the air quality from just growing things inside your space, right? With the respiratory droplets being in the air, there is the risk that anyone you're breathing out puts out these respiratory droplets. Like if you go outside on a cold day, right, you breathe out, you're going to see this cloud, right, coming out. Those are the aerosolized water droplets that come out from your lungs. And we can't really see that if enough of us gather in a room and keep breathing with no ventilation, we'll actually increase the humidity in that room because of just the air and the humidity coming out of our lungs, right? So that is a potential source of viral transmission, right? It is not very high, but that is one that people look into, which is why we have our recommended air changes per hour to help flush out all of that particular moisture in the air that could be carrying, droplets with pieces of virus in it, right? That being said, most modern systems have economizers in their air handling units to allow them to bring in a certain amount of outside air. Now, is not designed for outside flushes, really. It was designed to bring in cool air to cool your space instead of turning on your air conditioner, right? But what we can do is we can utilize that particular piece of equipment to bring in outside air. So we can open up the economizer for the outside air dampers and bring in more outside air via that way. But due to, as the weather changes and gets colder and colder in the wintertime, we're not going to be able to bring in as much outside air because the air handling equipment that heats up the air that comes into your space is not sized to be able to handle 100% outside air. So they size it for whatever the relative conditions are for our climate, right? So then different, we would size things differently here than we would like in Florida, right? So ours do have a little bit more leeway to go colder than, say, a unit that was designed in Florida. But eventually we hit a point around 40 degrees, maybe 45 degrees, where we're not going to be able to keep up, and our energy usage is also going to be going through the roof. That's where we go back to the filtration side of things and start recirculating the air. So because we can't bring in an outside air because our equipment now can't maintain to heat it up, we want to maintain comfort in our space, right? Make sure everyone's comfortable. We'll have to reduce that's where the recommendation is to reduce our outside air and circulate the air through these filters, right? So now you'd mentioned a HEPA filter. So I'll talk about those in just a second. Most HVAC systems are designed to handle between a MERV 8, sometimes up to a MERV 13 filter. Now a MERV filter, is there a way I can share my screen, actually?
Yeah.
Oh, no.
Got your lunch. Okay.
Yeah, is there
I
a
can
way?
stop sharing. You want me to stop sharing, Brian? You pull it in.
Oh, yes, please. Yeah, I'm just going to pull up my filter diagram.
Okay, go ahead. Pull up your
There we go.
folder. And
Yeah, the window. Okay, here we go. All right, I am new to this Google thing, so.
So do you have it in a on your computer?
It is, yeah, it's opened up in a window. Let me open it up.
Okay.
if you see the present now down below, Brian, you see that present
I do,
now on the
yeah.
bottom? Okay.
So
go ahead.
it has to be in a different browser session unless you're using Chrome.
Okay.
There you go. You got it.
Do this then.
It's
so
working
I'm
now.
sharing the email now. So I'm going to do this, and I'm going to move this over here.
Yeah. There you go.
All right. So
Perfect.
So now this is our MERV chart. So basically, a MERV rating is how efficient a particular filter is at capturing a particular particle size, right? So the particles are rated in what are called microns, right? So we have like 3 different columns here. So 3 different categories of rating for a filter. You know, the 0.3 to 1 micron, 1 micron to 3 microns, and 3 to 10 microns. 3 to 10 microns is kind of your dust, your hair, you know, that this particle is kind of floating around. Your 0.3 to 0.1 microns are going to be the virus is technically smaller than 0.3 microns, but it hangs around in a group and usually on particulates like moisture droplets, which are greater than 0.3 microns. So the recommendation, most air handling equipment is size, you know, typical for a MERV 8 pressure drop. So that's what most of them put in their units. It's 20% efficient at catching, you know, the 0.3 particles. And so it does capture, you know, some of the particles that would contain, you know, considered a viral load, but it's only about 20% efficient. So now moving up to a higher percentage filter, you're going to, like say the MERV 13, which is what ASHRAE and CDC recommends, it's about 75% efficient at pulling out these particulates, right? So it's not 100%. Even HEPA filters down here at the bottom, consider like MERV 20s would be the HEPAs. They're the 99.99%. They're still not going to pull everything out of the air. But the idea
but if I were in a situation where I was going to combine that, say, with people in the room wearing masks, I might be in a pretty safe environment if I could get a MERV 16 or 17 or 18.
That is correct. Yes. So it is a cumulative effect, right? So not one of these instances isn't, you know, 100%. It's the cumulative effect of all of these particular recommendations, right? So bringing in outside air when you can, and then running it through your MERV 13 or higher filter. There was a recent study that came out that was saying that the MERV filtering through a MERV 13 or higher filter is similar to bringing in 100% outside air. So when you cannot bring in outside air based on temperature and comfort, you know, and you can put a MERV 13 filter in, you know, then we can recirculate there through that. Plus, if you're wearing masks as well, that's another added protection. Or if you put a standalone HEPA filter in that particular room as well to circulate the air in that space, you know, it's a triple win. So.
Hey, Reed, let me just stop right. Hang on one second. Do we need to take a time check? I don't know. I didn't know how long you wanted us to go.
Yeah, so we're looking.
We allow time for questions or just open questions, you think?
Yeah, I just regurgitated a ton of stuff. So
no, well, this has been very fascinating. I think everybody is interested. If there is a question at this point, does anybody would let's just open your microphone or wave your hand at me, and I'll try to help you get online. I think this is very interesting, and you can go ahead. I think if we kind of look at another 10 minutes or so, that would be good.
Okay, great.
Yeah, all right, well, I'll just gonna keep going on the filters. So yeah, so the combination of the recommendations for a cumulative effect to help increase our viral load in the space, right? One of the because you know the viral droplets only go so far, and the minority of them gravity causes them to fall down. One of the important things, you know, hand washing, but also kind of sanitizing, wiping off the surfaces that you guys are around a lot. So the majority of the virus that's going to be coming out, it's going to be going straight down to the floor or the tables around you. So hand washing is critical. Washing the, you know, just washing off the tabletops and stuff is going to be critical. And then, like I said, with our outside air flushes, or like I said, increasing your filtration, and then wearing masks will all add to that, decreasing any contaminants that get into the air.
So I do have a little question here about you mentioned that a lot of the filtration equipment in commercial buildings that you work on are set up basically anticipating a MERV 8 filter. How flexible are those units in general, or are you able to upgrade the MERV, the quality of the filtration, or do you have to use secondary measures?
That's a good question, and honestly, it's been one for quite a bit of debate among a lot of engineers lately. But we finally kind of come to a conclusion. The filter racks on air handlers are sized to a certain pressure drop, so they can handle up to a certain pressure drop before they'll start caving in, right? And that's usually over an inch or 2 inches of what we call water column pressure. It's a pressure rating. So when you put in, the equipment is sized for a typical MERV 8 because of the pressure drop and the energy usage that it's going to use, and the less wear and tear on the equipment. And it looks better to a manufacturer to advertise their unit, hey, with this pressure drop and this energy rating. And so that's kind of the standard that they do. Now, most units, honestly, will be able to handle a MERV 13 just fine. It will increase your pressure drop on the top end a little bit, which means it's going to increase your energy usage a little bit. Plus, you will have to change them out a lot faster. So, because the MERV 13s are going to capture more particulate from the air, they're going to load up faster, right? It's like going, if you have an older vacuum cleaner, right, that you've used for a long time, and then you get like one of these newer, like a Dyson vacuum cleaner, and you're running it to the floor, and all of a sudden you're sucking up all this stuff that you never even knew was in your floor, and you're going, wow, okay. And then you have to, change out that filter a little bit more often, right? So what happens if you don't change out that filter in your new vacuum? Well, you're going to start losing suction again, right? So you just have to change it out more often, and that's a whole commercial, right? You have to change the Dyson out more often now. So you basically just going to have to, you will increase your energy usage, and depending on the type of equipment, on a smaller piece of equipment, like a residential air handler, it's going to be minimal. You might notice a little bit. On larger central air handling units, like we've done for some universities, we've had to do some engineering calculations, because that would increase their energy by a couple $1,000s a month. So just because that's how much the amount of airflow that they're using, right? Just giant, the size of a house kind of thing. Those types of units would be evaluated, and like I said, for their energy usage. But depending, in summary, it's very rare that an air handling unit would not be able to handle a MERV 13. With stipulations being, it will increase your energy usage, and it will need to be changed out more often. The main thing that kind of gave the MERV 13 filters a bad rap on, everyone was scared of putting these in their systems, is they load up faster, and so you have to change them out faster. So if you don't change them out, their threshold for your the wiggle room that they have is very minimal compared to like a MERV 8, where you can go a couple weeks, maybe even a couple months of having it loaded up, and your unit will be okay. If you do that with the MERV 8, you're going to overload your motor, and you could potentially pull the filter through the rack and all this other stuff. So
MERV 13 is what
MERV
you're saying.
13 or higher, yeah. Anything with a 75% more efficient rating or higher is going to create some more pressure drop. Now, they do have different types of filters that have high performance filters, which have more curves and ripples. So basically more surface area. If I pull this filter apart, it'd be like 5 feet by 5 feet. That's all kind of accordion together, right? Now those filters are the ones that we kind of recommend to reduce your pressure drop and decrease your energy usage while maintaining your higher filtration. So that answer your question?
Okay. Yeah, that's excellent. The only other, sort of the follow-up on that is the idea of ancillary filtration, like buying or putting in additional air purifiers. And I imagine that in some locations commercially, you're even looking at that. And certainly as a homeowner, I might look at that, or as a director of a senior center, I might look at that. Keith, did you have something to say?
No, I did not. I'm sorry. I had some background
okay.
noise.
Okay. And Jim is asking about Alexa Pure Breeze. I don't know that you want to get into specific products, but if you do know about that, that'd be great.
So as far as the HEPA filters and the standalone units, ASHRAE and CDC have been they haven't given a direct guidance on that. They have said that if possible, they haven't really called it a recommendation, but they have said if they would not recommend it, but what is the exact word they used? It wasn't recommend, it was something else, but
they're giving an inclination that one bit of information, maybe, I don't know, short of advice.
They can, short of advice, right? They can, they have been shown to reduce your airborne contaminants. And I personally, actually, I have allergy issues, so I personally use the higher filters in my own house. So, and I also kind of vouch for these types of systems in schools, because there's proven that increased indoor air quality helps a learning environment. So that's kind of my background in why I would recommend the HEPA filters. Now, as far as reducing your viral load, there's definitely evidence that, any kind of filter like the HEPAs would reduce those types of 0.3 micron particulates in the space to below any kind of level that would contaminate somebody or cause someone to get sick. So short of them.
Now, short of whether, I don't know whether you know about specific items, but like Jim's question about the Alexa Pure Breeze, but if you were, as knowing what you know, if you were going shopping for a filter, what kinds of questions might you ask?
I would stay away from the units that have the UV lights built into them. They're more expensive and they're not necessarily they're I don't want to call them a hoax, but the ability for that UV light to actually do any kind of purification apart from destroy the inside of the unit that it's in is negligible. So probably avoid the UV light ones. You're just going to pay for a fancy glowing light that looks cool. That's eventually going to eat your unit inside out.
Okay.
Go with kind of the highest HEPA rated filter with the more air changes per hour. Probably whatever ones that you're most comfortable with as far as sound goes, right? Some of them are louder than others. Some of them you can have an app on your phone. I think Costco sells them now that you can buy one that's actually attached to an app on your phone. So there's that route, but I would probably stay away from the UV lights would be my only really recommendation.
Okay. And I'm just gonna, any other questions while we're at this sort of break here, or? Okay. Well, let's see. Have you learned anything new about your work, your line of work, because of COVID? Has it opened your eyes to some issues that you might not have really thought about before?
Quite a bit, mostly on the filtration and airflow side of things. So there's been a lot of debate on how to, filter out a space. And so we've learned a tremendous amount on filtration and air changes per hour and other different ways of going about making those kinds of efficient changes. Because I come from the energy management background. So I'm save energy, save energy, save energy. And so it's breaking my heart to tell all these schools to open up everything now, but I just told them to dial it back in. So it's an interesting dynamic and learning curve. Yeah. So,
and I'll add to that a little bit if you don't mind, Rita. It's just it's amazing. It's just amazing how nobody was really prepared for anything like this, and it's going to open up, I think, just a continual debate about not only just reoccupying but going forward, just best ways for maintaining good air quality and filtration. I think it's gonna generate a whole new for us, it'll probably generate a whole new line of services that we'll be offering, and there's a lot of additional type work that's coming out of what we're doing. There's the filter change out, there's the control aspect, there's the re-looking at existing systems in place and old systems that don't have capabilities for introducing outside air, changing those out. So it's going to be a big kind of a big catalyst for a lot of things to come.
Great. Well, I want to thank you both very much. I've learned a whole lot in this brief period of time, and I think that the learning is going to go on. Is there any final comments that either one of you wanted to make?
And just one of the things we have been learning is just kind of the more awareness of the indoor air quality, right? So I've gotten into a lot of spaces where they thought their air was okay, and then doing kind of an analysis, you're realizing, oh, actually, you could be getting sick from your building. So even before all this COVID stuff happened. So it's been a good refresher course on helping people and understand their buildings and their indoor air quality needs. And
it will probably bring sweaters back as we try to keep the temperature a little lower as another way to.
That's a good campaign. That would be a good campaign there.
That's right. We're back to Jimmy Carter again. Anyway, that's before your time, Brian. But
I think I remember. I read my history. I read my history.
That's right.
I'm a history buff. So
okay. I want to
thank you so much. It's a pleasure.
This has been very informative, and we really appreciate it.
Yeah, it's my pleasure. Yeah, it's our pleasure.
Okay.
All right. Take care.
Yeah, you guys take care.
Okay.